virtualization, and virtualization means we are converting the hardware into software.
Okay, fine. However, first, VMware is a company, is the name of an organization. All right. Now, this organization develops many virtualization products, and out of which VMware vSphere is one such virtualization product. All right. So VMware, name of the company, it develops many virtualization products. Our product is VMware vSphere. However, what is virtualization? Now, there are many ways how you can define virtualization. Yep. Yes, Rupesh. Yep. All right then. Fine. VMware, name of the company, name of an organization. Now, this organization develops many virtualization products, and VMware vSphere is one such virtualization product. Now, we'll try to understand what is virtualization basically. Now, there are many ways how you can define virtualization. Okay. However, if I want to explain what is virtualization to someone who is related with IT, I would define that in this way. Guys, my voice is clear to you guys? Is it clear?
Yeah.
All right, fine. Now, what is virtualization? Now, virtualization is a solution to optimize resources which are available in your IT infrastructure. Okay, it's a solution to optimize the resources available in IT infrastructure. Fine. Now, it's a solution to optimize resources available in your IT infrastructure. Now, what is IT infrastructure? This is pretty basic stuff, but let me go ahead with the basic so that everyone understands. One of the guys said that he's new to this and he don't know anything much about virtualization. So let me consider each and everyone as the same, and let me go ahead with the basic stuff first so that everyone is on the same page. Fine. Now, what is IT infrastructure? Now, there are components put together forms your IT infrastructure. Have a look at the components. Components like servers, desktop, storage, network, and applications. Now, these are 5 components put together forms your IT infrastructure. Now, you name any component in IT, whether it is software or hardware, it has to fall under these 5 components or these 5 categories. And virtualization is a solution which can be implemented on any of these 5 components. That means it can be implemented on servers, desktops, storage, network, as well as applications. However, if I keep applications aside and implement virtualization on servers, then this can optimize the top 4 components, that is servers, desktop, storage, and network. So just by implementing virtualization on servers in my infrastructure, I am able to optimally utilize the top 4 components, which is servers, desktop, storage, and network. Am I clear, guys? All right. Now, what is a server? What is a server basically? When I say a server, what is a server, guys? What is a server, guys? Fine. However, from the perspective of virtualization here, server means 2 components. The first component, server, is nothing but a machine, the server machine, or we call it as a machine. All right. If server is a machine, then what are the resources available on a machine? What are the resources, guys? Server is a machine. Now, what are the resources on a machine?
Oh,
yeah, the hardware is your resource. Yeah, the CPU, the memory, the storage, the network, and the other devices. First, we'll talk about the hardware part, which is your resources. Okay. Now, who is going to utilize these resources? The second component of server, that is the operating system which is running on it. Now, normally on a machine, how many operating systems can we install, guys?
Not at one time.
One.
Can I install more than one?
Yes, we can install.
Yeah, you can.
Yes.
Yes.
Yes, we can install multiple operating systems. However, no matter how many operating systems I install on a machine, My machine has been designed in such a way that it can boot only one operating system at a time, right? So that means ultimately it comes to one. Agreed, guys? Now let us
Yes.
say I have installed Windows or Linux server operating system. Now what do these server operating systems do? What do, guys? They offer certain services, right? For example, Windows, a powerful service called Active Directory. The same thing in Linux is NIS. Okay. You also have DNS services. You also have the services like DHCP, right? And you also install applications on top of your operating system. Now, what is an application? Any software which runs on your operating system is an application. Application, Microsoft Office is an application. Exchange Server from Microsoft is an application. Databases like SQL databases, Microsoft SQL, Oracle, IBM DB2, Sybase, MySQL. What are these applications? ERP like SAP, Oracle Apps. What are these applications? So we also run applications here. Let me say that I'm running Oracle database here. Right now, I've listed out four services or four applications right now. Active Directory, DNS, DHCP, and Oracle DB, Oracle Database. Now, the first question, can I run all these services on the same machine? Can I do so?
Yes.
Yes, I can run.
Yes.
But should I run? Should I run, guys? People working in real time, they know that in real time, we do not run multiple services on the same machine. We do not mix multiple services and we do not run multiple services on the same machine. Though I can run multiple services, but I should not run. In real time, the ratio goes in this way, 1:1. What is the meaning of it? That means one machine, one OS, and one application on top of it. If this is the case, 1:1 is the ratio we follow in real time, then how many machines do I require in order to run four applications? Four machines, am I right? Right or wrong, guys? Now, I require four different machines to run four different applications or four different services. Now, we know that every machine is having its own resources, namely the same, the hardware. Every machine is having its own resources here. Now, as we are going with 1:1 ratio, that means every machine is running only one application. No matter how much load I put on that particular application, my CPU is not going to be utilized more than 10%. My CPU is not going to be utilized more than 10%. Whereas if you utilize your CPU up to 75%, then it is considered as optimal level of utilization. That means in physical infrastructure, as we are running only one operating system and one application, every machine in my infrastructure is being underutilized. Only 10% of its resources, specifically CPU, is being utilized. The remaining 65 to 70% is being wasted. So what is the solution in front of me to make sure every machine in my infrastructure is utilized properly or optimally utilized? The solution is implement virtualization on servers. Now, what this virtualization is going to do? It is going to abstract the hardware which is available. Then it allows you to create multiple virtual machines. Now, let me take the help of this presentation. Now, here, guys, virtualization can be implemented on any of these components. Now, traditional server architecture, guys, you have a physical machine on which you run one operating system on one application. So you have the resources, and here CPU utilization is only 10%. If you want to make sure every machine in your infrastructure is utilized up to optimal level, then the solution is implement virtualization. Now, this is virtual architecture where I have a physical machine and I implement virtualization using VMware vSphere, and this abstracts the hardware and then it allows you to create multiple virtual machines. Now, each box here is a virtual machine. Now, each virtual machine is running its own operating system and application on top of it. Okay. Now, what is a virtual machine, guys? What is a virtual machine? Any vague idea what is a virtual machine?
It's not real.
Okay, it's not real. Perfectly fine. Anything else?
Look of some file.
All right. Now, yep, what you said are valid points, but in a basic way in order to understand what is a virtual machine. Guys, a simple sentence will make you understand what is a virtual machine. Virtual machine is functionally equal to a physical machine. Virtual machine functionally equal to a physical machine. That means whatever a physical machine functionally can do, the same thing virtual machine can also do. So that means virtual machine, I can install an operating system and run application on top of it. If you see in virtual infrastructure, here there are six virtual machines running on your physical machine. Now each virtual machine is going to utilize a portion of the CPU. Thereby, my CPU will reach up to 75%. Then now I have made sure that my machine is optimally utilized by virtualization. That's the reason why virtualization is called as a solution to optimize the resources available in your IT infrastructure. By implementing virtualization, I'm making sure each and every machine in my infrastructure is optimally utilized, not only the machine resources, but also the other components like desktops, network, as well as storage can also be optimally utilized by implementing virtualization. Clear, guys? Now, yep. Now, we know that virtualization is getting implemented throughout the world in each and every IT infrastructure, whether it is small, medium, or large. Either virtualization has already got implemented in the IT infrastructure, or it is getting implemented right now, or it is yet to be implemented tomorrow. But this is the trend throughout the world. Now, why companies are implementing virtualization? Why are they implementing virtualization in each and every IT infrastructure? Guys, why the companies are implementing virtualization? What do you think?
To save the
Yep.
resource.
Yes, absolutely. Now here in physical infrastructure, if you want to host or run 100 applications, you require 100 physical machines. Now the same thing with virtualization. Maybe you can achieve the same task by just having 10 physical machines. You don't require hundreds of machines. Maybe you require less machines. Uh, 10 physical servers would do the same task. So companies are implementing virtualization because they're saving money. They're saving money on hardware, they're saving money on space, they're saving money on power. So overall, companies say that they're saving money greater than or equal to 40%. So here, some companies say they are saving more than 40, maybe 60 or 80, depends on the infrastructure, depends on the virtualization solution they are implementing. However, greater than or equal to 40% is the saving. All right, now this is the benefit of virtualization from the perspective of business. Now, who is saving this money? This money is being saved by the organizations who are implementing virtualization. But are we business, guys? Are we business? Are you business? Guys, who are you?
We are the persons going to implement it.
Okay, what are you called as? We are administrators, am I right? We are the people who manage the IT infrastructures. Now, what is the role and responsibility of an administrator? The role and responsibility of an administrator is to see that the operating systems, the applications, the network in your IT infrastructure is running 24/7. By any case, if it is down, to see that it is back up and running as soon as highly possible. This is the role and responsibility of an administrator. Now, let us see from the perspective of administration how virtualization is helping administrators in managing the IT infrastructure in a more better way or efficient way. Let us see that. Now, I'll take a small classic example. Let us assume that I have a physical machine. Okay. Now, on this, I have installed Linux, let us say, and on top of it, let us say I'm running Oracle database. Now, let us assume this Oracle database is working as a backend database to an online e-commerce portal. Let us say online e-commerce portal like redibus.in or maybe flipkart.com. Okay. Now, this database is working as a backend database to that online portal. Now, let us assume that on this physical machine, there is one hardware device which is malfunctioning. One of the device is malfunctioning, not frequently, but infrequently. Now, you as an administrator, you observe that particular task, particular thing, and you want to do maintenance on that particular server, or some sort of hardware maintenance. In order to do that maintenance, obviously, you need to bring the server down. Now, if you bring the server down, guys, can your Linux and Oracle database run? If you shut down the machine, obviously your operating system and the database is gone. It is also down. Am I right? Now, when you come across these kind of issues in real time, we go ahead and take up a planned downtime. It's called as a planned downtime, and we are going to have a plan. Most probably, we'll pick up, we'll choose a day where there is minimum load on this particular server. Most probably weekends, and the time most probably where there is minimum load on this particular application. Let us say on Sunday between 7 to 8 p.m. we are going to bring the server down for maintenance. And now for that 1 hour, this particular server or this particular application Oracle database would be down. Now let me change the scenario. Let me change the scenario here. Now my application Oracle database and my operating system Linux is not running on a physical machine, but they are running on a virtual machine. I have a physical server on which virtualization is implemented, and then you have virtual machines here, okay, and your Linux and Oracle database is running on a virtual machine. Let us say it is my VM, okay, and here you have installed Linux, and on top of it you are running your Oracle database. Now, keep this in mind that ultimately virtual machines run on physical machines. If there is no physical machine, virtual machine cannot exist. Now, the physical machine also has the same problem as this physical machine had. Let us assume that one of the hardware devices is malfunctioning, and you want to take up a maintenance task on it. If you want to take up a maintenance task, you need to bring the server down. If you bring the server down, your virtual machine is also down. Now, question will come to our mind. In physical infrastructure, there is downtime. In virtual infrastructure, also there is downtime. Then what is the benefit of virtualization? Now, here comes virtualization. What virtualization says, what VMware says is that if you come across these kind of issues where you have to take up a planned downtime, whatever the planned downtime may include, maybe a hardware maintenance or some sort of other maintenance task. Now, if you come across these kind of maintenance tasks where you are going to have a planned downtime, there is no need for your virtual machines, your operating systems, and your applications to be down. Without bringing these applications down, you can still continue with your maintenance tasks. Now, how is that possible? Now, for those who don't know how is this possible, it is possible in this way, guys. Now, as my applications are running on virtual platform, on virtual machines, now we have multiple servers in our infrastructure. Let us assume I have another server in my infrastructure where there is virtualization already implemented. And I told you that we are going to have a planned downtime, most probably Sunday, let us assume 7 to 8. Now, prior to 7, this physical server is running, my virtual machine is running, my Linux is running, and my Oracle is running. Now, at 6:30 p.m., you as a VMware administrator, what you do is that you start migrating a running virtual machine from one server to another server. That means you are migrating a running virtual machine from one physical server to another physical server. And slowly, this virtual machine, the running virtual machine, gets migrated from one physical server to another physical server without affecting your operations. That means your Oracle database is running, your Linux is running, and the end user who is connecting to this database, he may be entering certain data or retrieving certain data. He never knows that this particular application on this virtual machine is getting migrated from one server to another server. And he'll never know that it got migrated. And the virtual machine will get migrated seamlessly. When I say seamlessly, no network loss, no data loss. This beautiful technology of migrating a running virtual machine from one physical server to another physical server, VMware calls this particular technology as vMotion. Now, this technology called vMotion, I was able to migrate a running virtual machine from one server to another server. As this virtual machine got migrated to some other server, now I can bring this server down for maintenance, and there is no downtime for my application called Oracle. Now, if this was on a physical machine, then I couldn't have avoided this kind of downtime. But with the help of virtualization and the features like vMotion or the technologies like vMotion offered by virtualization, I was able to eliminate the downtime. So this is the benefit of virtualization from the perspective of administration. Virtualization is helping administrators in managing the IT infrastructures in a more better way, as well as virtualization is helping businesses to continue 24 by 7 without any downtime and eliminating the downtime. So this is the benefit of virtualization. This is also one of the major reasons why companies are implementing virtualization. Not only they are saving money, but guys, they are also able to eliminate the downtime for the applications, and it also helps improving business continuity and it increases the IT efficiency. So this is the technology of virtualization called vMotion. I'm able to migrate this from one server to another server. All right, guys. Now,
Yep.
did you understand this concept of vMotion, guys? Would you like to raise
Yeah.
any question on this? Yep.
Yep. Yep.
All right. Now, this is the reason why companies are implementing virtualization throughout the world. Not only because the savings, because of virtualization, the businesses are able to run 24 by 7, business continuity, and it is increasing the IT efficiency. All right. Now, guys, how many people know the history of virtualization? When did virtualization begin, basically? Any idea? How many years ago? 2 years, 5 years, 8 years, 10 years? Any idea, guys?
Maybe 10 years.
All right. Anybody else? All right. Now, as we are talking about virtualization and we are learning about virtualization, we would also like to know the history of virtualization. We should know the history of virtualization, basically. Now, guys, virtualization is not at all a new technology. It is a grand old technology. Okay, the idea of virtualization came into existence in 1960s itself and practically got implemented in 1970s. So virtualization is not a new technology. Now, which is the organization which implemented virtualization for the first time, or who invented virtualization for the first time? Name the company, guys. Any idea? '60s and '70s.
Maybe IBM?
Yep, absolutely right, Prabhakar. IBM, yes. Why IBM? Because the only machines which were available on the face of the earth at that particular time which can run a database were IBM mainframe machines. Now these machines were huge, large. They used to occupy a space somewhere around 2,000 to 3,000 square feet. One machine, such a big machine, powerful machine. The problem is it can run only one operating system and one instance of database. Just have a look at the figure, guys. Now, it's a typical figure of an IBM mainframe machine in the 1970s era. This entire thing is one big machine, guys. People are working inside the mainframe platform. Such a big establishment, one machine. The problem is that it can run only one instance of database. So IBM came up with a solution on these platform, and virtualization got implemented in 1970s itself on the mainframes platform. Now, if virtualization got implemented in 1970s itself, then why didn't our IT infrastructures utilize this technology called virtualization? Why didn't we utilize this technology called virtualization till recent years? There was no virtualization technology available, nor we utilized this technology called virtualization in our IT infrastructure till recent years. We started implementing virtualization. The inception was in the year 2001, but the IT infrastructure started implementing it from the year 2004, 2005, and slowly from 2009 onwards, it was like full-fledged implementation. Each and every infrastructure adapted virtualization, and they started implementing virtualization in their infrastructure. So that means 1970s till 2001 or 2005, whatever you maybe, there was a gap of almost 20 to 25 years. Now, why there was a gap of 20 to 25 years? Is virtualization not a good technology? No, it is a good technology, a powerful technology, a reliable technology. Then what went wrong? Why didn't our IT infrastructures use this beautiful technology and a powerful technology called virtualization? For that, we need to know a little bit about history. Now, guys, this virtualization technology was implemented on mainframes platforms in the 1970s itself. Since then, till today, you have virtualization technology available. since then till today, you have virtualization available on mainframes platform. But we did not utilize virtualization till recent years, as I told you, maybe from 2001 or 2005 onwards. What went wrong? Why there was a gap is because we need to know a little bit about history. As came 1980s, guys, the era of smaller computers came into existence. The era of small computer in the American market at the 1980s era. The machine was readily available. They had the machine ready with the design. All right. And what is important on a machine in order to make it functional? Right? What is required on a machine in order to make it functional? What is required on a machine in order to make it functional?
CPU, processor,
Yeah, that is the part of the hardware. That is the machine. Machine is ready now. I have all the hardware, but what is required? The other component required on a machine.
operating system.
Absolutely right. Absolutely right. The operating system. Operating system is required in order to make it make the machine functional. Now IBM developed that PC, IBM PC, but they didn't have an operating system. They wanted to outsource this. They outsourced this to Bill Gates. Again, I don't want to the history to go into the deeper history, what is what and how Bill Gates developed that MS-DOS. Bill Gates accepted the offer and he developed MS-DOS and gave this to IBM. And MS-DOS got installed on the IBM PC, and IBM PC became popular. And that's how the inception of smaller computers came into existence, and people started using the smaller computers. Now, as IBM PC became popular, the other smaller computer manufacturing sector came into existence. The other companies also started developing or manufacturing computers. And on the hardware part, the most important component is the processor. IBM, the machine manufacturing company, they know the technology, they know how to develop a processor. They were in a position to do that, but the other smaller computer manufacturers, they don't know how to develop a processor. At the same time, at the same era, Intel came into existence. I'm talking about Intel with many chips, but the specific processor they came up with, which is called as 8086. Now, this chip was specifically designed for embedded systems, starting with 8-bit guys. Later on, it evolved into a 16-bit processor. Okay, slowly it evolved into 32-bit. Now it is a 64-bit processor. And the smaller computer manufacturers started using this 8086 chip on their motherboards, and the operating system which got installed was MS-DOS. As time evolved, Windows came up with more better operating systems. At the same time, 1980s, POSIX-based operating system Linux came into existence. And throughout the world, when computerization got implemented in each and every IT infrastructure, those computers were based on 8086 chip or the 8086 processors. And more better operating systems, more better applications came into existence. And unfortunately, there was no virtualization available on this platform called x86. Guys, today we are using our laptops, our desktops, whether it is you're using your CPUs like i3s, i5, i7 from Intel or AMD, Athlon or FX8 processors. All these processors are from the root chip called 8086. In the same way, on servers, we use Intel Xeon servers and AMD Opteron servers. All these processors are from the root chip 8086. That's the reason why our machines, which we are using today in our IT infrastructures, are called as x86 architecture machines because the roots are into 8086 chip. That's the reason why it is called as x86 architecture machines. Guys, many people have a misconception stating that x86 means 32-bit. No, it is indicating the architecture of the machine, and we know that throughout the world, when computerization got implemented in each and every IT infrastructure, we started using smaller machines based on x86 architecture, and there was no virtualization available on x86 architecture until VMware came into existence. VMware launched their operations in 98 and 99. In the year 2001, they came up with the first server virtualization product. From 2001 till 2009, they came up with many products, but 2009 was the year where VMware launched their product called vSphere 4.0. Now that was the reason why there was a gap of almost 20 to 25 years where our IT infrastructure did not use virtualization because we started using the smaller computers based on x86 architecture and there was no virtualization on it. VMware, the first pioneer or the pioneer company to successfully implement virtualization on x86 architecture. So keep this in mind. There is virtualization available on mainframes platform since 1970s, but on x86 platform only from the year 2001 onwards. There was no virtualization on x86 platform. All right. So this was a brief history about virtualization. Now, why there was a gap of almost 20 to 25 years and different architecture machines available. Are there any other architecture machines available other than mainframes and x86 guys? Are you aware? Any other machines apart from x86 machines and mainframe machines? Any other machines in our IT infrastructures? Are you aware of any other architecture machines utilized or used in our IT infrastructures other than these? Anyone? All right. You also have other architecture machines like the operating systems, IBM's AIX. Are you aware of IBM AIX? HP Unix and Sun Solaris. Guys, are you aware of these operating systems? Like AIX, HP Unix and Sun Solaris?
Yeah, we don't have any idea about that.
All right. Guys, there are other architectures as well, apart from these, like X8086 is for our platform. Like there are operating systems like Microsoft and Windows get installed. Okay. And there are other architecture machines like IBM's AIX. AIX is the operating system developed by IBM. It's a Unix-based operating system, and this operating system does not get installed on our machines. It requires a specific hardware, and they get installed only on that particular hardware. And those machines are called as power servers or power series PS 5000. These kind of series are given. They have a different hardware, totally different hardware. In the same way, HP Unix, which is a operating system developed by HP, it's a Unix-based operating system, and HP Unix also gets installed on specific hardware developed by HP. And you have Solaris, previously Sun, now Oracle. Sun Solaris also has a specific hardware which is called as Spark machines or Spark servers, and they get installed only on those servers. Now, those operating systems run on a different architecture CPUs. Now, those CPUs are called as RASC CPUs, guys. I don't know how many people know about this, but those CPUs have a different architecture and they have a different design. And those kind of CPUs, whether it is on IBM's AIX, HP Unix, or Sun Solaris, they have RASC CPUs, reduced instruction set computing, and our x86 CPUs are called as CISC CPUs, complex instruction set computing. Okay, so on RASC platform also there is virtualization. On CISC platform also there is virtualization. Specifically CISC, we call it as x86 architecture. x86 architecture machines. So we have virtualization available on x86 architecture from the year 2001 onwards. Yeah, this was the history of virtualization and different architecture machines available and different operating systems running on it and different virtualization technologies available. However, VMware vSphere is the server virtualization product on the x86 platform. Clear with it?
So are these servers supported on VMware?
Try to understand this. That's the reason why I differentiated the architectures. Now, you need to understand that VMware vSphere is the server virtualization product on the x86 platform. Okay, I cannot implement VMware vSphere on RASC platform. It's a different architecture again.
Okay, so I cannot run these OSs on vSphere, right?
Yeah, you cannot run AIX. You cannot run HP Unix. Okay, and you cannot run Solaris Spark. Solaris has released two versions of its operating system. One operating system released to run on Spark hardware, and the other operating system released, they have released it to run it on Intel platform. However, on vSphere, I can run Solaris Intel. It is called as Solaris Intel. Okay, that means which can run on Intel CPUs, Intel or AMD based on x86 platform. However, Solaris Spark, no, I cannot.
Okay.
Now, these are the operating systems which I cannot run on VMware vSphere, but all the other operating systems which can run on x86 architecture machines, you can run it on VMware vSphere. Clear?
Yep. Yeah. Thank you.
Yeah. Welcome. Now, this was about the history of virtualization. However, the technology behind virtualization on machines are called as hypervisors. They are called as hypervisors, right? Now, basically, on the x86 platform, there are two types of hypervisors. Type 1, and you have type 2. Now, type 2 hypervisors are nothing but applications. What are applications, guys? Any software which runs on your operating system is an application here. Now, type 2 hypervisors run on an existing operating system, whether it be Windows, Linux, Novel Network, Solaris, whatever it is. It's basically an application which runs on your operating system, and this allows you to create virtual machines so that you can run your operating systems and applications on top of it. Now, type 2 hypervisors are also called as hosted hypervisors. These are good on your desktops and laptops, good for demonstration and testing purposes. These are not used in our IT infrastructures to implement virtualization. So type 2 hypervisors are applications. Okay. Now, to name a few products developed by different organizations, type 2 hypervisors. Okay. Name of the company, VMware. And VMware develops VMware Workstation. VMware Workstation is a type 2 hypervisor from VMware. Yeah, VirtualBox from Oracle, Oracle's VirtualBox, Microsoft Virtual PC, Virtual Server. These are all type 2 hypervisors from different organizations. These are good on desktops and laptops, good for demonstration and testing purposes. These are not used in our infrastructures to implement virtualization. Okay, and let me talk about type 1 hypervisors. Type 1 hypervisors do not require any base operating system. They run directly on the hardware. Okay, these are also called as bare metal hypervisors. You call type 1 hypervisor, bare metal hypervisor, or the server virtualization products. All are the same. VMware also develops type 1 hypervisors. Okay, and those type 1 hypervisors from VMware, the product is called as VMware vSphere. VMware vSphere is the type 1 hypervisor from VMware, and there are other organizations as well. For example, VMware vSphere is type 1 hypervisor. From Microsoft, you have Hyper-V. Okay, and from Citrix, there is another organization called Citrix. Citrix also develops type 1 hypervisor, which is called as Zen Server. Okay, and Oracle, which is an organization which also develops a type 1 hypervisor called Oracle VM. And you have an open source called KVM, which is based on Linux. It's an open source hypervisor, type 1 hypervisor. Now, these are all type 1 hypervisors available on x86 architecture platform, VMware vSphere, Hyper-V, Citrix, Zen, Oracle VM, and KVM. Now, however, VMware vSphere is the market leader with 70% of the market share. Throughout the world, 70% of the organizations implement virtualization using VMware vSphere. If you see the market share, 100% of Fortune 100 and Fortune 500 companies, Fortune Global 100, Fortune Global 500 companies implement virtualization using VMware vSphere. When it comes to mid-sized organizations, the recent survey says that 72 to 84% of the organizations implement virtualization using VMware vSphere. When it comes to small organizations, even small organizations are choosing VMware vSphere as their first choice. If they want to host any application which requires 24/7 support, and if they are looking towards ROI, return on investment, then their first choice would be VMware vSphere. Overall, on average, 70% of the market share is with VMware vSphere. Other organizations may go with Hyper-V, Citrix, Zen, Oracle, VM, and KVM. However, you as a VMware administrator, you can also manage, once you understand VMware vSphere and understand its architecture and work on VMware vSphere, you can easily manage Hyper-V, Citrix Zen, Oracle VM, and KVM without any training required, guys. I'm not saying just like that because I'm working and I've seen many people doing that, and many of my students who got placed in the organizations because they know VMware vSphere, ultimately they are working either on two hypervisors, VMware vSphere plus Hyper-V, VMware vSphere plus Citrix Zen, and some people only are working on Citrix Zen, and companies recruited them only because they know VMware vSphere. And the advantage of learning vSphere is that you are ready to work on any hypervisor on x86 platform. Because VMware vSphere explains you virtualization in such a way that you understand the simplest and the most complex component involved in virtualization. So because of this advantage and because of this understanding of virtualization, you are in a position to manage any other hypervisor without any official training required. But this is not vice versa. I've seen people working on Hyper-V, people working on Zen or Oracle VM and KVM. They cannot manage vSphere infrastructure without training, but the administrators of vSphere are able to manage the other hypervisors easily without any training required. So this is about the intro part or the basic stuff which is required for everyone who is learning virtualization. They need to understand a little bit about history, different architectures, what type of solutions are available in the market, and what is the position of VMware vSphere at the present scenario. All right, now let me talk about cloud computing a little bit here, guys. Are you aware about cloud computing? Anyone has an idea about cloud computing? Good. Now, guys, those who aren't aware of cloud computing, guys, usually cloud computing is provided as a service and is categorized into three types. IaaS, the first type is IaaS, IaaS. The second one is PaaS, PaaS, and the third one is SaaS, CSaaS. However, if I keep SaaS aside, IaaS, infrastructure as a service, and PaaS, platform as a service, these two cloud computing services are not possible without virtualization. So the foundation for cloud computing services like IaaS and PaaS is virtualization, and the driving force for cloud computing is virtualization. So someone is talking about virtualization, then indirectly they are talking about someone is talking about cloud computing, then they are indirectly talking about virtualization because cloud computing cannot exist without virtualization. The foundation is virtualization. Or if you ask me, 80% of the infrastructure configuration depends on virtualization. The rest is 20%, which is cloud computing software. And once you configure that, that will build a private or a public cloud for you. So this is about the introduction of virtualization and the basics ABCDs of virtualization. Guys, any questions on this? Whatever I've discussed till now? Any questions or queries on this? Were you able to understand what I said? Is it clear?
Yes, clear.
Everyone on the same page? Yep, guys. Any doubts, any questions, any queries, please do raise. All right. I'm here, guys. Yep. Who is this? Who is this? Rupesh? Rupesh, could you raise your voice? Could you raise your pitch? Your voice is pretty low. Yep, yep. Rupesh, could you repeat your question? Why? Because I was unable to hear anything. It's pretty low. Okay, okay, fine. Fine, guys. Just give me a moment. Yes. Who is this? Yep. You're saying you asked me that they are dependent or independent you're talking about? Did you say that? Yes, absolutely. See, usually cloud depends on virtualization, okay? And now what cloud does basically is that it allows you to access the virtual infrastructure from a remote location using internet, okay? Now, for example, I have my infrastructure available. Maybe my data center is located in Hyderabad, let us say. Okay, and this virtual infrastructure is created, and you want to access this virtual infrastructure from a remote location or from any part of the world using internet. In order to give that access, you require that cloud computing software, and certain softwares are used. Now, this software acts as a middleman, or it acts as an interface between the end user and your virtual infrastructure. Okay. Now, why usually this technology got its name as cloud is because the infrastructure is not at your end. It is somewhere else far from you, and it is accessible from any part of the world. Now, if you ask any child or a kid, what is a cloud? What will show you? He'll show you the sky, right? He'll show you somewhere else. No, there is a cloud. That means the infrastructure is not at your end on your physical premises. Your infrastructure may be in some remote location, and you're accessing that remote location that infrastructure using your internet and from any part of the world. So normally that's the reason why the technology got its name as cloud. And specifically, EAS and PaaS infrastructures are not possible without virtualization. They cannot exist without virtualization. And that in order to create the cloud infrastructure, you require softwares. Those are called as cloud computing softwares. And those cloud computing softwares sit on top of virtualization. Basically, they get configured on top of virtual infrastructure, and that's how they allow the end user to access your virtual infrastructure using a browser. Yeah.
So what are some cloud softwares like?
Yeah, VMware develops vCloud Director. VMware has developed vCloud Director, which is cloud computing software. Citrix has CloudStack. Okay, there are many open source like Eucalyptus, OpenQRM, OpenStack from from Red Hat people, from Linux, the people who are behind the KVM project. You know, so there are many softwares available. Using those softwares, you can create the cloud infrastructure. But keep this in mind: those softwares cannot do on their own anything without virtualization in place. First, you need to have virtual infrastructure created using VMware vSphere or any other virtual infrastructure, maybe Hyper-V, Citrix, Xen, or 2VM or KVM. So that is absolutely required. First, you require VMware vSphere. As I told you, 70% of the market share with VMware vSphere. First, you have to create the virtual infrastructure. Then use some sort of software, cloud computing software like vCloud Director, maybe OpenStack, maybe CloudStack, these kind of softwares to configure that cloud infrastructure, and then you can give the end user the access to your virtual infrastructure, right? No, we are not going to deal with cloud software guys. Why? Because this is purely VMware vSphere administration course. However, not to worry, let me inform you guys. I told you, cloud computing, 80% of it involves virtualization. Okay, the remaining 20% is only about that software, how to configure it, and how to get integrate that with your vSphere infrastructure or virtual infrastructure, and how to use it. So if you understand virtualization, then you understood the cloud computing 80%. The only 20% is left over. If you want, you can develop that skill on your own, or you can take up a course on cloud computing. That's up to you. But 80% of that depends on virtualization. And without knowledge of virtualization, no one can understand, nor manage, nor learn cloud computing. All right. All right. Fine. All right, guys. As today was our first session, it was to make sure that everyone is on the same page. All right. And tomorrow we are going to continue with our session sharp at 4:30. And I request all of you to be on time. And we are going to continue our sessions in that way. However, let me inform you about the infrastructure, what we have in our data center here in Hyderabad. The Zoom's data center, we have enterprise class servers, we have blade servers available, we have storage available, and the kind of infrastructure is enterprise class, and you can have a good hands-on practice on this infrastructure so that you get experience of real time, so that when you go out and work in infrastructure, you don't feel that which is different from what we have learned in our class and what we are doing here. It would be absolutely the same, no difference when it comes to the management part and the understanding of that infrastructure. So on and so forth. All will be real-time data center infrastructure with real-time practice, so on and so forth. All right, guys, any questions would you like to ask?
Can we practice at home?
Pardon?
Yeah, can we practice at home this one by using our laptops?
Yeah, you can do that, provided you have good resources available on your laptop or desktops.
Okay.
Bare minimum RAM you require is 8 GB. That is bare minimum, guys. It is absolutely bare minimum. It is not minimum. I'm telling you, bare minimum. Minimum, if you ask me, is 12 GB RAM. And recommended, I say that if you have 16 GB RAM, that's good. If you don't have this much amount of RAM available on your laptops or desktops, then it's very difficult for you to practice. That's the reason why we have our lab infrastructure. You can connect remotely and practice on our labs, on our infrastructure, not an issue. Yeah.
Okay, thank you.
Any other question apart from that? Could you please repeat?
Material.
The soft copy, guys? Yeah, whatever the training we are going to go ahead and continue, I think that material would be provided, and I suggest you to reach Mr. Srinivas regarding that, and when this material would be provided to you guys and how. I think the material would be provided, but when and how it is provided, I am not aware of. Fine. So you can contact Mr. Srinivas regarding that. Any other questions apart from that?
Thank you, Mujib. This is Srinivas here.
Yeah.
We'll be sending the material tomorrow. Okay, and like who are not registered, I request them to register and pay the fee. And who are paid and registered participants will get material tomorrow. I'll send you a link. From there, you can download the material. Okay. And tomorrow onwards, we'll be starting the session by 4:30. And I request all the participants to use the same invitation link which I have sent earlier yesterday. And with that, you can join every day. Okay. If there is any changes in the invitation link, you will be getting another mail with the link. Otherwise, the same mail link will be used. Anything else?
This is
Yes,
Vikas.
yes, Mr.
As you said, register. So is it a separate process, or like once we have paid a fees, it means we are registered, or is it like?
Registered.
Okay, that's fine then.
Yes. And is it possible, can we move the session to maybe half an hour, 1 hour below? Like instead of 4:30 Indian time, can we take up around 3:30?
It's fine with me, Vikas. Yeah, it's fine with me.
Yeah, even for me also it's okay. Prabhakar here.
Yeah, Mr. Prabhakar is okay. I think
Yeah,
both are
for
from
me. Yeah.
Mr. Sachinaran, Satya, Rupesh is okay. Mr. Hari, Mr. Satya.
Yes, can you ask again, Sri?
Can we move this batch, like we are starting now at 4:30? Can we flip on to around 3:30?
Yeah,
1 hour.
it would be very early for me, like 5 o'clock.
Okay. You are from US, right?
Yes.
There is another participant from US. He requested the timing. So
Okay.
I just okay. So it's not possible.
Um,
Okay.
yeah, that will be fine. Yeah, I'm okay with it.
With 1 hour?
Yeah, yeah.
Okay. So we can start around 3:30. Sorry, we
So,
can start around 3:30 Indian time.
Yeah.
so will that
Vikas?
be from tomorrow onward? So,
Let me check it up. Let me complete.
okay.
Mr. Sajay, is it okay with you? Can you put it on chart? Otherwise, if you are not able to look here. Okay, most probably. Yeah, most probably tomorrow we'll start at 4:30 only, and after tomorrow, let me just communicate with others also. Then we'll go with the 3:30 timings.
Yeah, like can we, like 30 minutes would be more good for me. So yeah, check with the time.
Yeah, 30 minutes. Okay,
I'm
I'll take
okay.
it.
I'm okay for Indian time, like 5:30 for me.
No, 4:30 Indian time, 4 o'clock. You are okay.
4 o'clock. Yeah, that's
Fine.
that's
Thank
more
you.
good for me.
Yeah. Fine. Thank you very much. Okay, I'm just ending the session. Okay, tomorrow onwards you can use the same link. Thank you.
Yeah, thank you.
Thanks so very much, guys. Catch you tomorrow at the same time then. Bye.
Okay, thank you. Thank you, bye.